Hello guys, hi everyone, welcome to Lead Electrical Academy. Myself G. Srikanth, I am pursuing PhD in Usmania University. In this lecture, I will explain what is transformer, what is the function of transformer, and what is the working principle of a transformer, what are the major parts are there in transformer. So transform means change of voltage and current. So transform means generally it is a change. And the next word transfer. So transfer electrical energy. So electrical energy from one side to another side. Then we can define a transformer like this. It is a static device. It is a static device which transfers electrical energy from one side to another side with changing voltage and current levels without changing frequency. So this is the definition of transformer. Static means it does not consist of a rotating parts. No rotating parts. Static device. That's why it is called as a device. So I will give one example. I want to transfer 10,000 watts from one side to another side. So generally the active power formula in an AC circuits VI cos phi. Let us assume the power factor of the line is unity. In a case 1, if a voltage is 100 volts, the current requirement to get 10,000 watts is 100 amperes. I am taking as a case 2 is if a voltage is 1000 volts and the current requirement is only 10 amperes. In a case 3, if a voltage is 10,000 volts and the current requirement is only 1 ampere. Let us assume the resistance of the line is also 1 ohm. That means the resistance of the winding is 1 ohm. The power loss formula, that is copper loss, I square into R. In the case 1, 100 volts square into 1, that should be 10,000 watts. But in a second case, power loss is equal to I square into R, that is 10 square into 1, that should be equal to 100 watts. So power loss in third case 1 square into 1, that should be equal to 1 watt. See, I want to transfer 10,000 watts and the 10,000 is loss. The useful power is 0 in the first case. In the second case, what is the useful power? Out of 10,000 watts, only 100 watts is the loss. That means 9,900 watts is the useful power. Coming to the third case, only 1 watt is the loss. That is 9,999 watts is the useful power. Tell me, students, which one is the best, case 1 or case 3? So obviously the case 3 is best. If a loss is minimum, then only utilization is maximum. In order to increase the voltages and decrease the currents, we require one device. That device is called the transformer. So the device is called the transformer. So transformer is a static device which transfers electrical energy from one side to another side without changing frequency and with changing of voltage and current levels. Okay, so that's why we require transformer in order to reduce the transmission losses. So I will give the power systems equivalent diagram. At the generating station, at the generator develops a 11 kV. That 11 kV is stepped up to 220 kV, and this 11 kV is stepped up to 220 kV. But in our homes we are using only 230 volts for single phase, 400 volts for three phase. So this we can't utilize this 220 kV. Why we are going for the higher voltages? Means in order to reduce the transmission losses. So again I am decreasing this 220 kV to 132 kV and 132 kV to 66 kV, and again it is stepped down to 66 kV to 33 kV, and again it is stepped down to 33 kV to 11 kV, and this 11 kV is stepped down to 400 volts, and we are having R phase, Y phase and B phase, and one more is there, neutral point. And we know that the phase voltage is 230 volts. In a star connection, V phase is equal to VL by root 3 and I phase is equal to IL. But advantage for star also discussed in three-phase circuits. Okay, that is V phase is equal to VL by root 3 and I phase is equal to IL. Neutral point is available in star. And what is the principle of operation of a transformer? Let us see. I am taking a soft magnetic material, that is silicon steel. I am taking a soft magnetic material, and the coil 1 is wounded on the soft magnetic material, that is silicon steel, and also called as it is core material. And the coil 1 has N1 number of turns and the coil 2 has N2 number of turns. This has N2 number of turns. I am giving a sinusoidal supply voltage. Yes, I am giving a sinusoidal supply voltage to coil 1. So we know that V is equal to Vm sin omega t or V equal to Vm sin of omega t something plus pi by 2. Definitely the alternating current will be flows. This is alternating current which is flowing through coil 1. If the current is alternating during positive of cycle, this is the current direction. Let us say I am taking two terminals. A source has two terminals. Let us say this is X and Y. X terminal is positive and Y terminal is negative. This is the current direction during positive of cycle. If you apply the right hand grip rule, rapid fingers represents the direction of the current, thumb indicates the direction of the flux. So the flux direction will be like this, and it will produce a flux. And this acts as a north pole and this acts as a south pole, because and externally the magnetic flux lines are from north pole to south pole, but internally it will be south pole to north pole. During negative of cycle, this X terminal is negative and Y terminal is positive. The current direction will be reversed. If the current direction will be reversed, means the flux direction is also reversed. Positive of cycle is like this, negative of cycle is like this, positive of cycle is like this, and the flux production negative of cycle is reversed. So with this alternating flux is linking with the coil 1 and coil 2. According to Faraday's law of electromagnetic induction, an EMF is induced in a coil 1 and coil 2. The E1 is called the self-induced EMF. E1 is called the self-induced EMF and E2 is called the mutually induced EMF. So mutually induced EMF. So what is a self-induced EMF means? It is a EMF induced in a coil as because of current flowing through its own coil. Because of current flows through its own coil. But it is a EMF induced in a second coil because of current flowing through first coil. So E1 is the self-induced EMF. E1 is the self-induced EMF. Self-induced EMF. It is the EMF induced. It is the EMF induced in a coil. In a coil due to current flowing through. Due to current flowing through its own coil. Its own coil. Coming to the mutually induced EMF. So mutually induced EMF. Mutually induced EMF. So it is the EMF induced. It is the EMF induced in a coil due to current flowing through another coil. You can observe this diagram. There is no physical connection between the coil 1 and coil 2, but same magnetic flux will be common. That's why these two coils, the above two coils are magnetically coupled, but electrically isolated. And this works on the principle of mutual induction. The principle is mutual induction. So if this core is a soft magnetic material, if this core is used as an air, so this is our diagram. You can observe this. The primary coil or the coil 1 consists of 1000 tons, and this one is another coil consists of 100 tons. If I am giving a sinusoidal supply, the RMS value is 2000 volts. The current is circulating through coil during positive of cycle and negative of cycle will be changes, and the flux will be produced. See here, the flux will be produced during positive of cycle is like this. The flux which is linking with the coil 1 and as well as the coil 2, an EMF is induced in a coil 1 and coil 2. If you are connecting a voltmeter, so based on the number of tons, if it is for 1000 tons is 2000, for 1000 tons is 2000, and 200 tons is obviously it is 10 is absent, 200 volts. The secondary side, so in a coil 2, the voltage is showing 200 volts. Now what is mean by primary and secondary coil, we will discuss one by one now. The same principle is used in transformer. Same principle is used in transformer, that is called the mutual induction. So I am taking a square shape of the core, and the coil is wounded on this transformer is like this. See here, the vertical portion of the transformer is called the limbs. Moreover, this is called the core type of transformer. Core type of transformer. The vertical portion of the core type of transformer is called the limbs. I have a two limbs, limb 1 and limb 2. On the limb 1, you can wound the winding with N1 number of turns. On the limb 2, you can wound the winding with N2 number of turns. I am giving a supply voltage here. I am giving a supply voltage, that is sinusoidal voltage I am applying. Then the sinusoidal current is flowing through coil, which will produces an alternating flux. So which will produces an alternating flux. This flux linking with the primary winding and secondary winding, an EMF is induced in a primary as well as the secondary winding. This winding we can say that it is a primary winding, and this winding we can say that it is a secondary winding. Secondary winding we can define like this: the winding which receives the supply, then we can say that it is primary. The winding which is delivers the energy to the load is called the secondary winding. So in this one, coil 1 is primary coil because we are giving a sinusoidal supply, and coil 2 is it is called the secondary coil or secondary winding. Secondary winding. You can use this secondary winding as a primary and primary winding as a secondary, vice versa. This alternating flux is linking with the primary number of turns and secondary number of turns. An EMF is induced in a primary winding and EMF induced in a secondary winding according to Faraday's law of electromagnetic induction. According to Faraday's law of electromagnetic induction. So what are the parts are there? The major parts of a transformer is one is a core and another one is windings. See, in this, the vertical portion of a core type of transformer or shell type of transformer. In the next session we will discuss that is a shell type of transformer. The vertical portion of a transformer is called the limbs. The top and bottom core is called yoke. Okay, this is about the principle of operation of transformer. The working principle is based on mutual induction. The transformer works on the principle of mutual induction. The same flux which is common for both the winding, if the flux is an alternating flux linking with the coil changes, an EMF is induced in a coil 1 or a primary winding and secondary winding. This is the principle of operation of a transformer. So if you go for the principle of operation of transformer, once again I am telling, whenever alternating voltage is given to transformer primary winding and alternating current flows through transformer primary winding, which will produces an alternating flux. This alternating flux linking with the primary number of turns and secondary number of turns according to Faraday's law of electromagnetic induction, an EMF induced in a primary as well as the secondary. This is the exact principle of operation of a transformer. One more thing, if N1 is greater than N2, we can say that if the primary number of turns are more, secondary number of turns are less, we can say that it is a step down transformer. Step down transformer. If N1 is less than N2, we can say that it is a step up transformer. Step up transformer. And if N1 is equal to N2, we can say that it is a isolation transformer. That is called the isolation transformer. So these are very, very important. And this isolation transformer is used in adapters. So adapters. So that is there for laptops. Okay. And next, the most important part is the constructional details of practical transformer. So constructional details of practical transformer. Practical transformer. So this we will discuss in the next video. Thank you.